they can't control it the way they'd like to. Secondly, this has a lot more functionality than our own virtual switch. If you'd like to use a lot of the capabilities that exist in the Cisco gear, you can now do that, and we'll take advantage of it. And then third, you get to manage it and use your command line tools the same way that you have on physical gear. So this really is a goal of removing objections from the networking team on fully virtualizing your data center. The networking team can be using their tools to control the virtual switch, while the VI administration team, or whoever is working on your virtual data center, can also do the quick provisioning and all the things that they're used to doing. Okay, so I just talked about all the bottom layer, and yesterday you heard a little bit about how we're really pulling this together, and some people get misty-eyed about the return of the mainframe. But what it's really about is aggregating a lot of this hardware into effectively a giant machine that you can then take advantage of. And so another big part of vSphere is making that giant computer even bigger. So versus today, we've moved up quite a bit of the statistics in terms of an individual, what we call a cluster. This has moved to a massive amount of RAM, a massive amount of IOPS, and on top of it all is DRS, our Distributed Resource Scheduler. And that's what it is that actually divvies up this giant computer safely and according to the service level agreements that you have in place. So this giant computer is there. You can have multiple of these giant computers within one virtual center implementation within one of your virtual data centers. And what we also want to do is have this thing that's capable of peaking to just great power, and again, DRS and some of our availability features working across all of your virtual machines. But we also want it to be very thrifty on the power side. So another very exciting part about vSphere is how we're taking advantage of power-saving technologies. On the CPU side, we're leveraging a lot of great CPU throttling and other power states that are available. And so I show a chart here of what we call VMWorld, an industry open benchmark for measuring how you're doing. This is running over about a 24-hour period, and it starts spinning up a number of virtual machines, getting to their peak throughput, and then over the course of time, those workloads finish, and you start to turn off the benchmark. In this case, we're leveraging a lot of the great CPU throttling and other power management techniques to lower power as the workload lowers even more. But what's very exciting about distributed power management is that we can even recognize many times this giant computer isn't fully needed. If you have peak workloads, you also have lower times when you can actually vMotion a number of virtual machines to a smaller number of physical servers. And in that case, we can actually power down some of the servers and only wake them back up when that horsepower is needed. So when you turn on distributed power management in this case, you can see we're actually not even powering on some of the gear until the workload has reached a level at which it needs it. And likewise, as you start ramping down later on, we're able to turn off machines when they're also not needed. So overall, the goal is to build this giant computer that is very simple to manage and can run your highest end benchmarks and workloads and have as much aggregation on it as possible, but also making sure you're only using the amount of power that you need. Okay, now we're going to move to the top level of the vSphere offering, which is really around providing services and allowing you to implement policies on top of the vSphere architecture so you can then apply them to all the virtual machines that are running. And the high-level vision we have for this is to really think about things differently. And when you go to deploy a virtual machine, one of your key applications, you should be able to assign a very specific policy to it. Here's an example. We want to give some notion of the availability that I'm after. I want to know if this is an extra secure system or not, and I'd also like to put in some level of performance service level that I'm after. And it really should be a contract that the virtual machine has, and when you deploy it onto vSphere, it is able to implement all of these different ones you're setting. And of course, in today's world, what you'll also do is get some level of cost back. If you want these particular settings, it's going to cost you $100 per month for that server. So this is the vision we have for this, and the beauty of the virtualization layer is that you can implement these policies outside of modifying the virtual machine. And that's a lot about what this layer is going to do. So the second biggest reason people have moved to virtualization initially after server consolidation has been higher levels of availability. And that's availability from hardware failure, certainly from disasters and other problems that you typically hit in the data center. And we at this point have been working on it for about 9 years and have focused on trying to attack planned downtime as well as unplanned downtime and attack it from the network level to the storage level and all the way up to the server level. So on the planned downtime, things like vMotion and storage vMotion let you proactively move a running virtual machine from one place to another with no downtime to the end users. Then you can work on that system and do whatever you need to do and then move them back when you're done. Unplanned downtime is when someone trips on a power cord. There's a little less we can do. We can't vMotion in that case. But we've come up with a number of ways of recovering very quickly, and in cases where there's redundancy, such as in fiber channel or in network technologies, we can fail over and take advantage of those opportunities. On top of all of this is what happens when your entire data center goes down. And that's when we introduced in June something called Site Recovery Manager, which I'll talk about a little bit more. Beauty of virtualization is that virtual machines are nice encapsulated files, and they can run on any hardware. So this has been a really hot way for people to move their applications to another data center and quickly bring them up. The last part of this is unplanned downtime when something on your server goes terribly awry. And one of my favorite capabilities within vSphere is fault tolerance. So let me make sure people understand what we're doing on that front. Today we ship a product called VMware HA. And the notion here is that we have this big computer, and one of the great things about it is if part of it dies, you can resume what was going on some of the other parts of that big computer. In this case, if the hardware dies, you have a power outage or something like that, what we'll do is automatically take those virtual machines and reboot them and restart them on another server that's available in this cluster that you've created. Now this is doing a reboot. That means that you are losing state that was in place, but for a large number of applications that had no protection, this essentially means if hardware goes down, they'll be up and running again. But we also wanted to attack higher-end workloads that can't deal with having to restart, and that's what fault tolerance is all about. Picture looks very similar. This is something taking place on this giant computer. And what's going on in this world is that you are constantly taking one virtual machine, that's the one on the left here, and as it executes, we are actually creating a shadow virtual machine running on a second piece of hardware. This is running on a completely different server. And because of the beauty of this layer, we're able to see every single instruction, every piece of memory that's touched, every I/O transaction, and we can actually send it over to the other server and have it deterministically execute exactly as the first one did. So the Shadow VM is trailing along very closely behind the first virtual machine, and it's not sending things out on the network. We're stopping it from doing that, or else the world would get confusing, but it's always ready to take over. And so when this piece of server goes down, we seamlessly cut over to its Shadow virtual machine. And this is pretty amazing. It is picking up at the exact same instruction boundary, complete data is in place, and it's true FT. But what's extra exciting is rather than investing in very high-end hardware that does this complete replication, we're now doing this in software. And what's more, it's very flexible. On a per virtual machine basis, you'll right-click on your virtual machine and you'll decide this is one that is extra important to you, and you'll say enable fault tolerance. What this means is that you're only choosing to explicitly burn an extra core and use some of the network bandwidth that this takes for those applications that you want it to. So very much about giving you choice and how much you'd like to pay, if you will, for this extra level of availability. So we're hearing some really interesting things about this as people are trying it out. To some extent, you can think about this as you have this big computer and pieces will die, and I've heard some customers talking about, well, that's great, we'll let it die, and fault tolerance automatically reprotects once it's done this failover. So it will spin up another shadow virtual machine on another piece of hardware. And as a result, as some of the servers go down, you can actually know that it'll be reprotected, and then at an appropriate time, you can go back in and maintain and change out those servers that have died. So a very exciting capability that will bring a new level of availability to the industry standard architecture that we're using.